All right, so we can also do stoichiometry with gases. So if you thought stoichiometry was going away, it's not. It's throughout all of Gen Chem, you will need to know how to do stoichiometry. So if that's something that you're still struggling with, you need to get some practice ASAP, and you need to, get caught up ASAP. Let's take a look at an example question. How many liters of oxygen gas are formed when 294 grams of potassium chlorate decomposes? Assume a pressure of 1 atmosphere and a temperature of 298 K. And then I'll also give you the equation. So 2 potassium chlorates as a solid will decompose to 2 potassium chlorides as a solid and 3 molecules of oxygen gas as a gas. Remember, oxygen gas is one of our diatomic gases, so it exists as O2. All right, so think about kind of what we want, what we have, that kind of thing. We've got our equation, right? PV equals nRT. And if we think about what our question is asking us, it's how many liters of oxygen gas. So what we want is volume. But remember, we can only ever solve for one variable at once. So let's go ahead and figure out what other pieces of the puzzle we have and what we have to figure out. So the pressure we're given as 1 atmosphere, pretty simple there. The temperature we're given as 298 K, pretty simple there. R is the gas constant, so that's always the same, 0.0821 liters atmospheres over moles Kelvin. And then finally, the last piece of the puzzle is our moles of oxygen. So this is something that we're not given directly. So we have to think about how we're going to solve it. Remember that moles is just a different way of saying amount. And in this case, we have grams, which is another way of saying amount. So we can use that piece of data to figure out our moles of oxygen. And again, this is stoichiometry. So we have 294 grams of potassium chlorate. Almost any time that we're given grams, we want to go to moles using the molar mass of the compound. In this case, the molar mass of potassium chlorate is 122.55 grams per mole. My grams goes down on the bottom, so grams cancel out. Note that if you're given moles in the beginning, don't go to grams. And then this is moles of potassium chlorate, but what we want is moles of oxygen gas. So when we go from moles of one component to moles of another component, we have to use our stoichiometric coefficients. So our stoichiometry is telling us for every 2 potassium chlorates, we get 3 oxygen gases. So let's go ahead and add that into our equation. For every 2 potassium chlorates, we get 3 O2s, and we can cancel out the perchlorates, or the potassium chlorates. And now what we're left with, the units that we're left with, are our moles of oxygen gas, which is exactly what we need to plug into that equation. So solve through this, you get 3.5985, with this 9 being the sig fig. And then what we're going to do is we're going to rearrange our equation to solve for N, or my bad, for V, my bad, V, volume is what we want. So V is equal to nRT over P. And now we start the plug-in and the chug-in, right? So our N is 3.5985 moles. Our R is our gas constant, which we know is 0.0821 liters atmospheres over moles Kelvin. Our T was given to us as 298 Kelvin. That's approximately room temperature. So if you keep seeing 298 pop up, that's why. And then our pressure was given as 1.00 atmospheres. It's not really going to do anything there, but we will cancel out the units, moles with moles, atmospheres with atmospheres, Kelvin with Kelvin, and you'll see that we're left with liters. go ahead and plug and chug through there, and you'll get 88.0 liters of oxygen gas as our final answer. Again, stoichiometry, a lot of students struggle with it. We really need to get good with it. You cannot do chemistry without knowing how to do stoichiometry. If you're struggling with this, check out the work along, check out the extra resources page or sheet. That'll link you to some, extra worksheets that you can work on. And then, of course, if you're still confused, stop by office hours or a free tutor to get some more help. But you got to get it under control.